Hello everyone, welcome to today's class. In this session, we are going to have a very good topic, application of robotics in space. In this session, we are going to cover the introduction of the robotics in space and the types of robots, importance of robots in space exploration, and what are the advantages and the disadvantages. About the introduction of the space robotics, actually, it is a specialized field of focused on designing, and developing, and deploying the robotic systems for use in space exploration and operations. Unlike robots used in the factories or Earth, space robots must function in the extreme conditions: zero gravity, intense radiation, vast temperature fluctuations, and without direct human supervision. They are essential in conducting the missions that are too dangerous, distant, or repetitive for humans. Over the years, space agencies like NASA, ISRO, ESA, and Roscosmos have relied heavily on robotic technology to explore the Moon, Mars, asteroids, and even the outer planets of our solar system. Next, the types of space robots. There are several types of robots used in the space. Rovers are mobile robots designed to travel across the surface of the celestial bodies of robots in the space. NASA's Mars rovers like Spirit, Opportunity, Curiosity, and Preservations have provided the invaluable data about the red planet. Lander, such as Vikram from India's Chandrayaan 2, are designed to descend and remain stationary while conducting the experiments. Then robotic arms are often mounted on the spacecraft or space stations and used for repairs, docking, or handling the satellites. As seen with Canada's famous Canadam on the International Space Station. Other types include orbiters, humanoid robots for onboard assistance, and satellite servicing robots that help repair or refuel the satellites. The next, we are going to see the importance of the robots in the space exploration. Space robots are critical to extending the human reach into space. They serve as our eyes, hands, and instruments in distant environments. They can collect the soil and the rock samples, perform chemical analysis, take high resolution images, and search for signs of water or life. Robots can go where humans cannot, into deep underground caves or hostile atmosphere like Venus. Importantly, they can work continuously without rest, ensuring maximum productivity. Robotic missions are also far more cost effective than crewed mission and pose no risk to human life, making them ideal for preliminary exploration and data collection. Next, we can see the role in satellite deployment and maintenance. Space robots play a major role in launching, deploying, and maintaining the satellites. Robo arms and manipulators help to install these satellites into proper orbit or service them if they fail. NASA's robotic refueling mission is a great NASA's robotic refueling mission is a great example of robo refueling satellite in the orbit. A task previously impossible. In future, autonomous robotic spacecraft may be able to extend the life of expensive communication or weather satellites by performing regular servicing. This is not only saving the billions in replacement cost, also reduces space debris, one of the growing concerns in the space operation. Next, we can go to the use of the robotics in the International Space Stations, that is called ISS. The International Space Station is one of the most advanced hubs for testing robotic system. The Canadarm 2 is a robotic arm used to capture and dock supply ships and move astronauts or equipment around the station. There are also internal robots like Astrobi, a cube-shaped flying robot that assists astronauts with the inventory inspection and monitoring tasks. Humanoid robots like Robonaut 2 are designed to work alongside astronauts, perform tasks, and eventually take over more hazardous duties. These robots help to reduce the workload and enhance the safety of astronauts on long missions. Next, we can go to Mars missions and surface exploration. Was one of the most studied planets using robotic technology, beginning with the Sojourner in 1997. NASA has contributed continuously sent the advanced rovers to explore the um, Martian surface. Perseverance, the last rover, is equipped with the tools to analyze geology, search for signs of past microbial life, and collect the samples to be returned to Earth by future missions. It is also carried by a small helicopter called Ingenuity, which became the first robot to fly in the thin Martian atmosphere. These robotic explorers have laid the groundwork for the future human efforts by mapping terrain, finding water sources, and identifying the safe landing zones. Finally, we can move on to the final part of the today's class is the future of robotics in space missions. The future of space robotics is very promising, with missions planned to the moon, Mars, even Jupiter's moon, Europa. Robots will continue to be at the forefront. Next generation robots will have artificial intelligence capabilities, allowing them to make decisions, reroute paths, or adjust experiments autonomously. Swarms of mini robots may explore vast terrains together. Robots will play a key role in lunar base construction, resource extraction, and life support system maintenance. NASA and ISRO's planned moon missions also include autonomous robots for surface exploration and infrastructure development. As technology improves, robots may even assist in long duration crewed missions to Mars. So that's all today's class. Thank you for watching this.